Hey everyone, and welcome back to the final part of our series. So in the last episode, we finally trained our tiny GPT model, and today we're going to wrap everything up. So in this video, we'll be learning how to evaluate our model, save and load the checkpoints, and finally generate the text in Shakespeare style. So if you're ready, let's get started. Hey everyone, and welcome back to the final part of our series. So in the last episode, we finally trained our tiny GPT model, and today we're going to wrap everything up. So in this video, we'll be learning how to evaluate our model, save and load the checkpoints, and finally generate the text in Shakespeare style. So if you're ready, let's get started. So after we train our model for a while, we need a way to check how well our model is trained. So what this function does is we'll make a function called evaluate. It will run on the model's validation set and the part of data that we didn't actually train on. And it will measure the average loss after checking this data. When the loss gets smaller, it means the model's predictions are getting more accurate and more closer to the real next tokens. So this is basically like a progress bar of how much the model has learned so far. And since this part doesn't need gradients or updates, we will use the @torch .nograd like to make it run faster and use less memory. So let's go ahead and write it out. @torch no gradient, define evaluate model valdl and device. So we'll put model.evaluate losses equals make a list. Now we'll say for xb and yb in valdl xb yb equals to xb.to device and yb.to device. Then we'll put loss equals model xb and yb, and we'll now append these losses. Append loss.item. Now we'll return it. Return float np mean losses. And now after this, we have to make a save checkpoint function. So because the training will take time, so we don't want to lose our progress if something crashes or we stop the training early. So the function will save the model's weights and configuration into a single PT file. Think of it like if you're like playing a game and you save your game progress, you can pick right off where you left and without starting from the beginning all over again. And this is the same. We'll just pick right off where we stopped without having to train the model again each time. So now let's make it. So we'll put define save checkpoint model tiny GPT cfg GPT config token SP tokenizer and we'll put the path at str. So now we'll make the OS directory first. os.path name. Actually, we'll put os.path dot directory name. We'll say path exist okay equals true. Then we'll make torch.save and we'll say model. We'll actually make a string model state model.state dict. And now for CFG, we'll just say CFG dot dict. Okay. And after that, we'll just put path. So now that we have the save checkpoint, we should also make a load checkpoint. So to make the load checkpoint, we'll say define load checkpoint. We'll put path str again, sp model str. Then we'll say check equals torch dot load path map location equals CPU. CFG equals GPT config. And we'll say double asterisk chk and put CFG here. Now we can make the model and say tiny GPT and put CFG configuration. Model.load state directory chk, the model state which we defined earlier, and model.evaluate token will be sp tokenizer. We'll put sp model. Return model and tokens. So now that we have everything ready, now we should make some command like helper functions that will make it super easy for us to run everything from the command line. So basically we won't have to edit the code each time we want to try a different prompt with the model. So for example, we can make a train tokenizer function, we can make a preprocess function, a pre-train function. This will all make it easier to just run everything from the command line when we are trying out our model. So let's begin, and first we can make the train tokenizer. So we'll say define command train tokenizer arguments train sentence piece. We're just calling the sentence piece function that we made earlier. Args.input args.prefix args.vocab size. And that's it. Now we can make the preprocess function. We'll say define command preprocess. Put args again, and we'll put preprocess text to IDs. Args.input args.sp model and args.output args.out. Now we make the command train function, the pre-train actually. Define command pre-train args. We'll say pre-train, say mpz at equals args.data sp model equals args.sp model. Now we'll put checkpoint output equals args.checkpoint, and we'll say block size equal, we'll say block size will be equal to args.block size. and we'll put batch size equals to args.batch size. And now we should put the number of heads as well. And actually we should include the model first. DModel equals args.DModel. Number of heads equals to args.number of heads. Number of layers equals to args.number of layers. DFF equals to args.DFF. Dropout equals to args.dropout. Learning rate equals to args.learning rate. Max steps equals to args.max steps. Now we'll put the warm-up equals args.warmup, and gradient clip equals args.gradient clip. So yeah, that's it for the pre-train function. Basically what this one does is actually start the training. It will load the tokenized dataset, it will build a model, and it will run the training loop that we already covered earlier. You can even tweak the parameters like max steps and maybe demodel or even batch size right from the command line. This is actually an important function to add because it gives us a lot of convenience, and it just allows us to run these experiments without actually going back to the code editor each time and manually changing the code from here. And now for the fun part, we will be creating the text generation. So we'll make the command, let's call it generate. This command will load the saved model and tokenizer. It will take in a prompt, like any prompt, like the beginning of a poem, like to be or not to be. And you can adjust like creatively with like, you can set the temperature lower, it will make it more predictable. If you set higher, it will be more random. And then you can set the top K, which will limit how many possible like next tokens the model chooses from. So you can make it sound more serious or creative by just tuning these factors. So let's go ahead and create it. We'll call it define command generate. Put args. We'll say device get device model token equals load checkpoint args.checkpoint args.sp model model.to device. We'll say prompt IDs equals to token.encode args.prompt. Alright, so we'll just take the prompt and we'll encode it into numbers, or we'll call it IDs. So next we should make the x equals, we should make the tensor equals prompt IDs, and we'll say d type equals torch.long device, and we should make device equals to device. Basically this is the setting the batch of size 1, and here in the model.to device, basically we're moving the model to like run on our device. Basically it's like important to run these code before, like as a requirement, we have to do this. So now we'll say with torch dot nograd y equals model dot generate x max new tokens equals args.max new tokens. Then we can say for args.max new tokens, we'll also put the temperature equals temperature equals args dot temperature. Then the top query we'll put top k equals args dot top k. Okay, so now we should make the decode, which will be, let's say, output or out equals token dot decode, let's say y 0 dot to list. Okay, now we'll print it. Print, let's say, and equals prompt equals, then we'll put n. And now we'll add to show the prompt, args.prompt. Now we'll also print, we'll put the completion, so we'll say, this is just to create a new line, completion. If you put /n basically in the print, it will, like, always, whenever you mention /n, it will jump to a new line. And then we'll put out. So it will run the output function, the decoded function right here. Now that we have created the generate command function, we should now build the last part, which will be the arg parser, like build arg parser function. Basically, this is the last function that will connect everything together. It uses the Python's argparse library to read what we type in the terminal. Like, and each command, like train tokenizer or generate, has its own options, meaning you can control the model size, learning rate, temperature, all without touching the code itself. It's a small feature, but it makes our script feel more professional and more convenient to use. So let's go ahead and type out define build arg parser. We'll say p equals argparse dot argument parser. Argparse dot argument parser, and we should put the description. Description equals tiny GPT. We'll just put a basic description. It's the minimal GPT plan. This is basically the main parser of our function. Then we'll put sub equals p dot add subparser. Destination equals to command required equals true. Okay. Now we train the tokenizer, so we'll put p.token p.token equals sub.add parser train tokenizer, and we'll put p token.add argument, and we'll say input required equals true, help equals raw text file, and this will be the path to the raw text that we're doing. And now we'll also add another argument, token add argument. We'll make the prefix default equals tokenizer, and we'll put tokenizer slash sp. And for the help, we'll say like help equals, we'll say output prefix. Without dot model. Okay, this will show where we are saving the train progress. Now let's add another argument. Token.add argument. We'll say vocab size. Let's spell like this. Vocab size. Type equals integer. Default equals 8000. And now we should now make the handler token.set defaults. Function equals command train tokenizer. So now we'll make the pre-process, and let's go ahead and write preprocess preprocess sub.add parser preprocess, and we'll say preprocess dot add argument input required equals true. Required equals true. Then we'll say p.preprocess add argument sp model default equals tokenizer slash sp model. preprocess dot add argument. We'll say out. We'll set the default to data slash processed slash corpus IDs. It will be like slash corpus IDs dot mpz. So basically the SP model we did here, the first we did the input, which will be the raw text path, then the SP model we added, which will be the trained tokenizer, and this will be the output. We'll make it go to output.mpz. Okay, now we'll set pre-progress set defaults function equals command pre-process. So once again, the pre-process command we just made, it will be to handle our preparing our data set. So it will the functions we defined, like input, the arguments we defined, for example, input, which will show the path to our raw text file, the SP model, which will show which tokenizer model to use, and the out, which will show where to save our processed MPZ file. So later on we can directly run all of this directly from the command prompt. So now let's create the pre-train. So basically what we will do with the pre-train part, we'll command, is that it will actually train our TinyGPT model. We'll give it a bunch of arguments to control how the model trains. So let's go ahead and make it. We'll call it, let's see, we'll say p.pretrain equals sub.add parser pre-train. Then we'll say, now we're just gonna add the arguments. Add argument. Data required equals true. Pre-train dot add argument. We'll say SP model. Default equals tokenizer slash SP.model. Now I'll be explaining all of this in a second. Let's first of all create the code. Pre-train dot add argument. We'll say checkpoint. Default equals checkpoint slash tinygpt.pt. Then we'll say p.pretrain.add argument. Block size. Type is integer. And default will be 256. Pretrain.add argument. Batch size. Type integer. Default 64. pt.add argument. Tmodel. Type int. Default 256. Add argument. We'll say number of heads. Type integer. Default 4. Add argument. Number of layers. Type integer. Default 4. pt.add argument. We'll say dff. Type integer. Default 1024. Pretrain.add argument. We'll say dropout. Type equals float. Default is equal to 0.1. Pretrain.add argument. Let's add learning rate. Type equals float. Default equals, so 3 to the power of minus 4. Add argument. Let's say the max steps. Type integer. Default 2000. Add argument. Warm up. Type integer. Default 200. Pre-train.add argument. Gradient clip. Let's say type is float. And default is 1. Now p.pt.set defaults function equals command pre-train. So basically what we did here was give it a bunch of arguments to control how the model trains. So data for tokenized dataset, SP model will show which tokenizer to use, checkpoint where to save the checkpoint, and block size is like how much context or how much like information it can look at, and batch size which will show how many samples per training step, then the number of heads, model, D-model, number of layers, DFF, this is the model size, and dropout will be the like regularization, like it will drop out 10% of the text. LR is the learning rate, max steps is how long to train, warm up will show how many steps to like warm up the learning rate, and the gradient clip we added is like a safety limit for the gradients. We have covered all of these actually before, all of these specific variables. We're just like now setting like or like enabling the model to have these access to these arguments to control how the model trains. And finally, we'll make the generate function. So let's go ahead and make p generate sub.add parser. We'll put generate. So what this line is like, it will load the trained model and lets it write text. And now we can also like control the options here on how the text generation behaves. Like we'll just make a checkpoint like we did earlier. We'll make a checkpoint, we'll make the SP model, which will show the tokenizer which model to use. We'll give the prompt argument, which will be the starting text that we will provide the model. We'll put the max new tokens. It will show like how long the generated text should be. Then we'll put the temperature and the top K. So basically control the creativity and show how many possible tokens to sample from. So let's go ahead and make it. So we'll put the gen add argument. Checkpoint. We'll say default equals checkpoints slash tiny gpt.pt. Then add p generate.add argument SP model default equals tokenizer slash SP dot model. P generate dot add argument with the prompt. Default will be, let's say, once upon a time. Now p generate dot add argument we should put this. We'll say max new tokens. Type equals integer. Default, let's say, will be 100. Now p generate dot add argument temperature. The type will be a float. Default is 1. Now we'll put p generate dot add argument top k type integer default, let's say, equals 50. P generate dot set defaults function equals command generate. And now finally we'll return p. So the p is the parser, and finally we will make the final code. It will be, this is actually important for these kinds of code, we have to include this. If name equals to main, then we'll say arguments equals build arg parser dot parse arguments. Then we'll say arguments function arguments. So actually this part is really important because it makes sure that this file runs only when we execute it directly, not when it's, like, for example, imported somewhere else. Then it will read the commands that we gave and it will run the functions correctly. So when you, like, use the command prompt, and I'll show you earlier, and you state the prompt, it will know exactly what to do. So before moving on to the command prompt, I noticed there were a few typos with the code, so let's go ahead and fix them real quick. And in line 17, the true should be with a capital T. Line 20, we'll put the vocab size will be equal to vocab size instead. Then over in line 33, we should make the get pieces. Yes, there's a 2 S's. We should only make it 1 S. Get pieces size. And over in line 33, instead of get pieces size, we should put get piece size. So get piece size. And then over in line 39, we should put output. We should make it, instead of output, we should make out.mpz. Okay, so in line 46, we should make train IDs equal to IDs, and we should put this in between. And line 47, value IDs, it should be IDs. We should put the minus nval first, and then the, yep, there we go. So in the line 48, we should go ahead and make the OS directory, and we should put out mpz. And we changed it earlier, so it's all good. And in dataset, which is in line 59, we should make the get item, define get item self, and instead of IDs, we should put IDX. So that will be IDX right here. And line 65, instead of the class GPT config, it should be with a capital letter, GPT config. And line 74, but yes, line 74, it will put the class casual self-tension and nn.module. Have we done that? Class casual self-attention and nn.module. And line 75, we'll put define init self GPT config. Instead, we should have put define init self and say the model number of heads and drop out. Line 77, then we'll put assert the model number of heads equals 0. This is fine. Line 80, we'll put self dot head dimension. It will be the model divided by n heads, number of heads. Then line 81, we'll put self.qkv equals nn.linear dmodel 3 times dmodel. Okay. And line 96, then we'll go to line 96. It should be self dot, instead of self, we should just put f dot softmax. Alright, so f dot softmax, and it should be attention dimension equals -1. So line 98 after that, it should be y equals att at, and then we should put v. Since we have defined v earlier, instead of value, it's v, which is the same meaning, but the naming of the variable is important here. Then over the transformer block, we will put in line 107, it should put, so instead of casual self-tension, causal self-tension we should put. And we should also change this in the line 74 as well. Causal self-tension layer. Okay, so after that, in line 110, instead of we should just change it to nn.linear dmodel and d.f, dff. So this should be nn.linear, and over in line 107, instead of the dot here, we should put a comma. And in line 116 to line 119, which would be here, we should make sure that these are inside the init. So we should bring these a bit back, because they are not nested inside the init function. Okay. And line 122 is next, where we'll put define init. We'll put define init self, and the CFG will be with GPT config. Okay. And at line 123, we'll put self. We should also add a super.init. And in line 129, we'll have cfg.dropout. So there's a typo here. So it should be dropout. Then we should have over to line 155, which will be, we should Yes, here we go. It should be temperature. So there's a typo here as well. Temperature equals to 1.0. Then line 162, it should be top K. As you can see here, there's a typo, so it should be top K. Then line 171, we'll put the lock size, which should actually be block size. And then line 172, it will be, here we'll put the gradient clip, so without the S. And the max steps here should be equal to 2000. We should put the equals there. Then in line 175, we have the number of, there's a typo as well again. It should be number of heads. Okay, so and line 181, we'll change the batch size typo. Batch size. And line 190, we should change the scalar. So let's see. Scalar equals torch.suda.amp gradient scalar. Okay, so then we should put enabled equals torch.suda dot is available, and that should just be there. Enabled equals torch.suda.is available. And now in line 198, we should change another typo, xb yb xb.toDevice yb.toDevice. I believe we should put the equal sign here. There we go. And line now 202, we should put here with torch. Yes, we should put the here as we're putting it, we're nesting it. Okay. So then in line 205, if gradient clips, it should be if gradient clip is not none. And line 207, parameters, we should put model.parameters and a comma here instead of the dot. Then line 211, we should put model.parameters again. Okay. We should also delete the lines from 29 to 212 as it's just a duplicate. We've actually written it twice. So we'll put here. Okay. And then in the evaluate, we'll put in line, let's say, in evaluate, we'll put for xb yb in val dl. It should be for xb yb without the comma. So, and in line 234, so then in line 240, we should find the CFG. We should put 2 underscores. Okay. So line 256, we should put the args. There's a there's a typo here. args.out. Line 260, we should put mpz.path. Then line 262, checkpoint, we should put checkpoint.out. And line 263, we should put the block underscore size. Then in the line 284, we should put temperature equals args.temperature. Okay, and line 287 should be, and then completion, it should be together. Then in line 301, we should change the tokenizer /sp dot model, not underscore model, sp dot model. And line 302, we should change the corpus. There's a typo here, corpus underscore ids.mpz. Then line 312, we should change it to, there's a underscore here, in here, number of heads, it should be a minus or a dash. So if we go up as well, we should make the changes to import in line 8. We should put import torch.nn as functional as f. Then in line 16, we should put over the vocabulary size at the last integer equals 8000. Then in line, let's say 22, we should add the model prefix equals model prefix as well, as we are missing that. Model prefix. Then in line 38, we should put return self.sp.decode IDs list map integer IDs. But however, there is a extra parenthesis, so we should remove that. And next in line 40, we should put the, over here there is a error as well, where we should change the, we should put like input txt str, input txt str sp model str. Then there is a missing comma, as you can see here, after the output mpz str, so we put a comma. Then over in line 82, we have two equal signs, so it should just be one. So self.qkv and one equal sign. And now in line, let's say in line 83, self.out equals nn.linear dmodel 3 times dmodel. However, it should just be dmodel and dmodel. And line 84 as well, there's two equal signs, so remove one. Then over in line 86, we should change it to torch.trill. And we should add the, let's say we should add one more parenthesis here. Actually, we should add a dot. It should be torch.14096 unsqueeze.0. Then in line 96, one of the parameters is wrong, so we'll just put, yep. And we'll go down over to, let's say, let's check with torch. Let's actually remove the typos here. So line 161, there's, we should add temperature again. Then Let's go to with here in line 203. Okay, here in line 203, we should add with torch dot suda dot autocast. We'll just remove this. We'll put enabled equals torch dot suda dot is available. Then we will head over to return float, line 235, and here we should put it just like so. It's not inside the loop, it's outside the loop, the return function. And finally, in line 203, instead of the line with torch.suda.amp, we have to add it. So I just checked earlier, it's the correct API. So now that we're done with all the typos, we can now head over to the command prompt and test out our model. Now let's open our command prompt. So first what we need to do is to change the directory to our LLM project. Then we should open the virtual environment. So we'll put Python -m virtual environment dot virtual environment. Then we activate it. So we'll put dot virtual environment slash scripts slash activate. So now we should install the old Shakespeare text into the dataset. So in order to do so, we type out curl -l and then use the link I have sent, which will be included in the description below as well. Okay, so now we have the dataset installed. Now we need to train our model on the text. So we'll make the code which will read our raw text and build a sentence piece model. So in order to do so, we write out Python tinygpt.py train tokenizer, and the input, which will be the location of where you have stored your text. So you basically do data /raw /input.txt, then prefix tokenizer /sp, then we'll put vocab size, we'll set it to 8,000. So now you should see here that it says that train sentence piece at tokenizer sp/model, and this is the output that we have specified in our Python code. Now we can pre-process the dataset, which basically will convert our text into token IDs in like as numbers, and then this will split into train and validation sets. So let's go ahead and type out Python tinygpt.py pre-process input data /raw /input.txt sp model tokenizer /sp.model. Then we'll also put the output out data /preprocessed /corpus ids.mpz. Okay, so next we'll pre-train the tinygpt model. Basically, this will run the training on the tokenized data. You can set the number of states. I will show it now. But for now, let's put 1,000 steps as the max steps. So let's write out Python tiny gpt.py pre-train data slash pre-processed slash corpus IDs.npz sp model tokenizer slash sp dot model. Then we'll make the checkpoints slash tiny gpt dot pt. Then the max steps will be, for this tutorial we'll say 1,000, but usually the more you have, the more accurate the model will be able to replicate the text of Shakespeare. But however, the more you have as well, the longer time it will take. So to keep this tutorial like shorter, we'll choose 1,000 steps, which will look similar to the style of Shakespeare. But usually if you do it like much higher, it will look exactly like Shakespeare text. Now it seems there was an error, but this is, I think, because of the corpus IDs, it should be with a dash instead of underscore. So let's just go ahead and change this. Corpus IDs dot npz sp model was a sp model tokenizer slash sp dot model checkpoints slash tiny gpt dot pt. Then the max steps 1,000. So now our model will start to train. And as well, before training, we should also make the directory as well. So we'll say make directory checkpoints. So once you run that, you should now see the progress bar as the model is getting trained. You can set the max steps to any number you want, depending on the performance of your device. So here I just set it to 200 just to make sure the process runs faster. Now that we have pre-trained our model, we can now generate the text. So let's go ahead and write down Python tiny gpt.py generate checkpoints slash tiny gpt.pt and sp model. Then we'll do tokenizer slash sp.model. Then we'll put the prompt. Let's say we'll say the king said. Then we'll put max new tokens at 80. Temperature at 0.8 and top K at 50. So when we go ahead and run this, we should now get the prompt and the completion. As you can see here, the model has successfully been able to mimic the style of Shakespeare. And this, we have only done this with the max new tokens at 200. However, if you do it more like 500 or 1,000 tokens, if your device can handle it, as it's usually like a heavy load. So if you do it as higher max new tokens, like 500, 1,000, 2,000, the higher it is, the more accurate and the more similar it will look to the Shakespeare's text. So, and there we go. We have now successfully built the model and generated the text. And there we have it. We have now concluded the series. So we have built a tiny GPT model entirely from scratch using Python and PyTorch. If you found this series useful, please make sure to subscribe and like the video and hit the bell notification so you don't miss the next videos. Also, I would like to just announce that I have created an X page and it is linked in the bio of the channel. So make sure to follow the X page for more information and real-time updates as well. Thank you for watching, and I hope to see you in the next video.